Hello everyone. Welcome. Today we are going to explore chains in LangChain. First, we will understand why to use chains in LangChain. Chains are invaluable due to their capacity to effortlessly blend diverse components, shaping a singular and coherent application. Through the creation of chains, multiple elements can seamlessly come together. Imagine this scenario. A chain is crafted to take in user input, polish it using a prompt template, and subsequently pass on this refined response to a large language model, LLM. This streamlined process not only simplifies, but also enriches the overall functionality of the system. In essence, chains serve as the essential, seamlessly connecting different parts of the application and enhancing its capabilities. Furthermore, chains provide us with the ability to build complex applications by linking multiple chains together or by incorporating chains with other vital elements. There are many different chains in LangChain that we can use. But in this video, we will go through two of the fundamental chains, LLM chain and sequential chain. First, we will create the virtual environment with follow this command. Our virtual environment has been created. Now we will activate our virtual environment using name of the virtual environment /scripts/activate command. After activate the virtual environment, we will create the requirements txt file to write down the required libraries for this project. Now run this command to install all the required libraries. All the required libraries has been installed. To run our chain, we need LLM. Now for LLM, we will use OpenAI. Now, we set up our environment variables. These variables include our API keys for OpenAI, which we will store securely using a.env file. This ensures our sensitive information stays safe. Create the .env file. Put your OpenAI_API_ key here. To get the OpenAI API key, open your browser and type OpenAI API key and sign up. Now click on API keys and click on Create API key. Copy the API key and paste it in .env file. First, we will understand the LLM chain. The most basic form of chain within this system is the LLM chain, widely recognized and fundamental. Its operation involves a structured arrangement, including a prompt template, an OpenAI model, and an optional output parser. Within this setup, the LLM chain accepts various input parameters. It employs the prompt template to transform these inputs into a coherent prompt. This polished prompt is then inputted into the model. After receiving the output, the LLM chain uses the output parser, if provided, to further refine and format the result into its ultimate usable form. To illustrate the functionality of LLM chains. Now, let's see the example of LLM chain. So create a new Python file to write the code. Next, we will load our OpenAI API key from a.env file to keep it secure and initialize our model with a specified temperature setting, which controls the creativity of the responses. For that, we have to import OS and dotenv. Import OS. Import dotenv. Now, initialize the model. LLM equals OpenAI. Temperature equals 0.9. OpenAI_API_key equals OS. Getenv. OpenAI_API_key. Next, we will design our prompt, so we have to import prompt template. From LangChain.prompts import prompt template. Now, we will define a prompt template to input a variable, in this case, product, and create a standardized prompt structure. At runtime, the placeholder, a product, can be dynamically populated with different product names. Prompt equals prompt template. Input_variables sadface product. Template equals what is a good name for a company that makes a product. Next, we will create an instance of the LLM chain class using a predefined OpenAI large language model and a specified prompt template. Now, we have the capability to apply the chain to a product such as a gaming laptop using the chain.run command. This means the chain can dynamically process and generate responses tailored to this specific product input. From LangChain to chains import LLM chain. Chain equals LLM chain. LLM equals LLM. Prompt equals prompt. Verbose equals true. Print chain.run gaming laptop. Based on this, we will get the name of a company. Now run the file. You can see the output of the chain. That's how the LLM chain works. Next, we will under the sequential chain. A sequential chain is a chain that combines various individual chains, where the output of one chain serves as the input for the next in a continuous sequence. It operates by running a series of chains consecutively. There are two types of sequential chains. Simple sequential chain, which handles a single input and output, and sequential chain, which manage multiple inputs and outputs simultaneously. First, we will see the example of simple sequential chain. Simple sequential chains allow for a single input to undergo a series of coherent transformations, resulting in a refined output. This sequential approach ensures systematic and efficient handling of data, making it ideal for scenarios where a linear flow of information processing is essential. So, delete this and leave model initialization. We will create a specific chat prompt template with a placeholder for a product name. Subsequently, we form an LLM chain, which allows the generation of responses based on the provided prompt. We repeat this process for two different chains. First underscore prompt equals chat prompt template. From underscore template. What is the best name to describe a company that makes a product? Chain underscore 1 equals LLM chain. LLM equals LLM. Prompt equals first underscore prompt. Second underscore prompt equals chat prompt template. From underscore template. Write a 20 words description for the following company. Company underscore name. Chain underscore 2 equals LLM chain. LLM equals LLM. Prompt equals second underscore prompt. Now, create an overall simple sequential chain comprising two different individual chains, chain underscore 1 and chain underscore 2. Execute this with the input, gaming laptop. It sequentially processes the input through the defined chains and provides an output that demonstrates the step-by-step sequential execution of the chains. Overall underscore simple underscore chain equals simple sequential chain, chains sad face chain underscore 1, chain underscore 2. Verbose equals true. Overall underscore simple underscore chained. Run. Gaming laptop. You can see the output of the simple sequential chain, where output of the first chain serves as the input of the second chain. Now, we will understand the sequential chain. Not all of the sequential chains operate with a single string input and output. In more intricate setups, these chains handle multiple inputs and generate multiple final outputs. The careful naming of input and output variables holds important significance in these complex chains. A more general form of sequential chains allows for multiple inputs/outputs. Any step in the chain can take in multiple inputs. First, we will create the input variable name review and initialize the review with the French paragraph. In this example of sequential chain first underscore chain will translate the French paragraph in English. Second underscore chain will summarize the English translation and third underscore chain will write the follow-up response based on the summary. To create the input variable review first, we will delete all of this and leave the model initialization. I think we will update this prompt. So I already have the French parad. So I will copy it and paste. Now, we will define a prompt template, instructing the system to perform a specific task. We then create a corresponding LLM chain using the designated large language model, LLM, and the defined prompt template. The chain is set up to take the input, pass it through the LLM, and generate the output. We repeat this process to establish 3 distinct chains. First underscore prompt equals chat prompt template. From underscore template. Translate the following review to English. \n review. Hashtag chain 1. Input equals review and output equals English underscore review. Chain underscore 1 equals LLM chain. LLM equals LLM. Prompt equals first underscore prompt. Output underscore key equals English underscore review. Second underscore prompt equals chat prompt template. From underscore template. Can you summarize the following review in one sentence? \n English underscore review. Hashtag chain 2. Input equals English underscore review and output equals summary. Chain underscore 2 equals LLM chain. LLM equals LLM. Prompt equals second underscore prompt. Output underscore key equals summary. 3 underscore prompt equals chat prompt template. From underscore template. Write a follow-up response to the following. Summary in the English language. NN summary. Hashtag chain 4. Input equals summary, language, and output equals follow-up underscore message. Chain underscore 3 equals LLM chain. LLM equals LLM. Prompt equals 3 underscore prompt. Output underscore key equals follow-up underscore message. Now we will create overall sequential chain named overall underscore chain, incorporating 3 individual chains, chain underscore 1, chain underscore 2, and chain underscore 3. The input variable review is processed through these chains, generating 3 distinct output variables, English underscore review, summary, and follow-up underscore message. Overall underscore chain equals sequential chain. Chains sad face chain underscore 1, chain underscore 2, chain underscore 4. Input underscore variables sad face review. Output underscore variables sad face, English underscore review, summary, follow-up underscore message. Verbose equals true. The overall underscore chain executes the input review through the specified chains and produces these outputs, facilitating a structured, sequential processing flow with detailed outputs. Print overall underscore chain review. You can see the output of the sequential chain. First underscore chain translate the French paragraph in English. Second underscore chain summarize the English translation, and third underscore chain write the follow-up response based on the summary. So, in today's video we covered LLM chain and sequential chain in LangChain. That's it for today's video. Hope you enjoyed the video.